Hi everybody, this video is going to start Unit 11, which covers quadrilaterals. This page is kind of our introduction page, our table of contents basically. It's on page 59. If you turn the page, we will start 11.1. So this is 11.1. In Unit 11, we're talking about quadrilaterals. A quadrilateral is a four-sided polygon. And what we really need to know in this unit is that quadrilaterals, the sum of the angles adds up to 360 degrees. So our last unit was on triangles, those were 180, but we get to quadrilaterals and they are 360. So for instance, I've started off number 1 here. To find out our missing angle, we would add 80 plus 116 plus 70 and subtract all of that away from 360. And so that's kind of what I did here. I just made it into an equation, but it's the same thing. So if we add these together, we get 266, and so we then subtract 360 minus 266, and that will give us our answer. And so this comes out to be 94 degrees. Now I just called it F because it was F in the picture. You can call it X or whatever you want, but I just called it F because of that. So similar thing over here. I'm going to add up the four angles, and 85, 95, and 96. I'm going to add those together, and then I'll subtract that from 360. So if I get my calculator and I add these together, I'm going to get 276, and what I'm looking for is angle M, and that should all add up to 360 degrees. So I take 360 minus 276. So again, I go to my calculator and I get the answer is 84 degrees. So this angle is 84 degrees. So all four angles add up together to be 360. All right, well, what if we put variables in there? Well, the same thing. We're just going to add up the four of them. And so 120, and then I put these in there, and I put this in there for 19x plus 1. So I just add all four of these together and set it equal to 360. And then we know how to add these. We want to add our like terms, and so I'm going to add up 120 plus 6 plus 1 plus 65. So I go to my calculator, and I believe that is 192. And then I add up my x's, and I have a 9x and a 19x, and that's 28x. And I'm going to set that equal to 360. And so now I just solve my equation. So I'm going to subtract 192 from both sides. And when I subtract that on my calculator, I get 168. So now I divide by 28, and I get x equals 6. Okay, and then this is one of those where they asked us to go back and plug it in, because we just solved that x equals 6, so I have that. I know that angle C is 120 and angle B is 165. So 120 and 65, I can fill those in. The next thing I want to do, though, is I want to take this 6 and plug it in here for the E and here for the D. So 6 plus 9 times 6. And I go to my calculator and I work that out, and that comes out to be 60 degrees. And then on this one, 19 times 6 plus 1. I'm going to go to my calculator, and that I get 115. Now, if I double check it, I should be able to add these up to get 360 also. So I know that's 180, and this is also 180, so yeah, it will add up to 360. Why don't you take a minute to try to solve this one? I set it up for you. We're going to add up all four angles, set them equal to 360. Take a second to solve this and see what you get. Okay, probably something I should have clarified in the beginning, which I think you probably picked up on, but this angle, it has a little square in it. That means it's 90 degrees. That's where that 90 came from. That's what that is. So when I solve this equation, I get x equals 7, so I know that's 7. I know that x, and I should probably also clarify, this is a capital X, and this is a lowercase x. So there's a difference there. But capital X, the measure of angle x, is 84 degrees. Angle y is 90 degrees, because that's what that little square means. And then to find the other ones, I have to plug in the 7 to figure it out. So I'm going to take 14 times 7 plus 2, and I'm going to work that out. And so I put that into my calculator, and I get 100 degrees. So angle W is 100 degrees. And then on this one, 12 times 7 plus 2, I work that out. And that comes out to be 86 degrees. So that goes there. So if I add these together, it should come up to 360. And I went to my calculator and I double checked it, and it does add up to 360. Okay, so that's how we're going to do equations with our quadrilaterals. So we started off this page talking about quadrilaterals. Quadrilateral is a four-sided polygon, but there are a lot of more specific quadrilaterals, and that's what we're going to talk about at the bottom of this page. So down here we have the definition of a parallelogram. It's a quadrilateral with both pairs of opposite sides that are parallel. And we have this little symbol. You all know that parallel, like if I was going to say that AD is parallel to BC, I use this double line thing. That means parallel. But if I'd want to draw a marking on here, I use these little arrows. For instance, these are parallel. So DC is parallel to AB. And then I can come over here and say AD is parallel to BC. So if it has one arrow on it, they're parallel to each other. If it has two arrows on them, these are parallel to each other. Let's go to the next page. Okay, if we have a parallelogram, so everything on here is specific to parallelograms, opposite sides are congruent. So this side is congruent to this, and this side is congruent to that. Opposite angles are also parallel. So this angle is congruent to this, and this angle is congruent to this. Same side interior angles of a parallelogram are supplementary. Do you remember what supplementary means? Supplementary means they add up to 180. So I could say that, like, for instance, angle A plus angle B adds up to 180. Or angle B plus angle C adds up to 180. So any two angles that are right next to each other are going to add up to 180. And that's because they really are like a transversal. And so we learned that in transversals. These are parallel lines with a transversal. Supplementary, the same side interiors are supplementary. And then lastly, the diagonals bisect each other. Diagonals are ones that go like through the middle across like this. They don't connect the ones right next to it. They skip one over. And so they bisect each other. Remember, bisect means cut them in half. So this is congruent to this, and this is congruent to this. So each of those pieces, they are bisecting each other. So in this next part of the examples, we're going to go through some examples and see if we understand what it means. So this one goes back to the very top. Opposite sides are congruent. That is, this is congruent to this. So in other words, x is 10. Okay, this one talks about the angles, and we have a rule that says that the opposite angles are congruent. So that means x is 106. Then remember, if they're next to each other, this is if they're across from each other, this is if they're next to each other. If they're next to each other, then they add up to 180. And so that means that x is 105. Because if I subtract 180 minus 75, I get 105. We also had a rule that said that the diagonals bisect each other. So if I look at my diagram, that means x is 12 and y is 8. Okay, this one's going to take a little bit of work. It's a little bit longer. If we look at this 113 and we look over here, w is also 113. So that's something that can help us out. Then what else? Well, we can take advantage of the fact that we know these are parallel to each other. And I'm drawing them really long because we're going to talk about a transversal, which we've done before. We've done transversals before. So if I look at this, then I should be able to look at angle 39, for instance, and say that this angle is congruent to this angle because they are alternate interior angles. So x is 39 degrees. So I have 113 here, I have 39 here, and a triangle is supposed to add up to 180. So now I could say that 113 plus 39 plus angle z adds up to 180, because that's a triangle. So if I add these together, Then I get 152 plus z is equal to 180. So I subtract my 152 from both sides. And I get my answer, z is 28. So z here is 28 degrees. And if z is 28, then alternate interior angles says that y is also 28 degrees. So now we have all of them. This is 28, this is 113, this is 28, and x is 39. So we're done. That one took a lot of work. The last one here is not as long. This side is congruent to this side. And so we can just say that 20 equals 9x plus 2. Or maybe 9x plus 2 equals 20. So if we subtract 2 from both sides, we get 9x equals 18. We divide by 9, and that gives us x is 2. Okay, we have one more page for this video. Let's turn the page. Remember, these are across from each other like that. That means that they are equal to each other. So I can set up an equation. I subtract 4 from both sides. That gives me 8x equals 64. I divide by 8. I get x is 8. So this should be 68. 8 times 8 is 64 plus 4. There you go, it's 68. All right, this one though, they are not across from each other. They are next to each other. And when they are next to each other, they do not equal each other. They add up to 180. So I can add my 2 plus 70 to get 72. I'm going to subtract my 72 from both sides. That gives me 36x is equal to 108. So if I go to my calculator and I divide by 36, then I'm going to get 3. X is 3. So same side or supplementary, but across from each other like this, they're going to be equal. Okay, there's a lot going on in number 9, but it's really not too much. We were told in our rules that these are congruent to each other and these are congruent to each other. We're going to do two separate equations. We're going to say 2x equals x plus 5. And then separately, we're going to do 3y minus 7 is equal to y plus 3. So this one will give me my x, this one will give me my y. So if I subtract x from both sides, I get, and that's like subtracting a 1x, so I'm going to get x equals 5. That was good, easy enough. This, I'm going to subtract my y. That gives me a 2y minus 7 equals 3. I need to add 7 to both sides, so I get 2y equals 10. I divide by 2, and I get y equals 5. And if I plug those back in, they should come out to equal each other. So like 5 plus 3 is 8, and 15 minus 7 is 8. That works. 5 plus 5 is 10. 2 times 5 is 10. That works also. Okay, the last one, again, there's a bunch going on, but we can just separate it into two separate problems. Because we have the two sides that are across from each other, so we can set those equal to each other. So 2n plus 3 is equal to 3n minus 15. And then separately, we have these angles, and the angles are also across from each other, so we can set them equal to each other. So now I'm going to go through and solve. I'm going to go like backwards on this one. I don't like getting negatives, so I'm going to go this way. So I'm going to subtract 2n from both sides. So that gives me 3n minus 2n is 1n. I'm going to add my 15 to both sides, and I get n equals 18. And then if I go to my y's, I'm going to do this, set it up so these are equal to each other. I'm going to subtract 3y from both sides. That gives me a 3y plus 4 is equal to 37. I need to subtract my 4, so I get 3y equals 33. If I divide by 3, I get y equals 11. All right, that was a lot of work for today. We will do the ed site in class.